Welcome back. Now we will talk about mechanical energy. Kinetic energy, you all know it's 1/2 mv squared, where v is the speed of the body, and potential energy is mgh, where h is the height above the ground surface. And the mechanical energy is defined as sum of the kinetic energy and potential energies, which is this one. So this is the mechanical energy. So potential energy, gravitational potential energy is this one. But there are different kinds of potential energies which we'll learn in the later stage. But for present case, the gravitational potential energy we will consider as a potential energy. Then conservation of energy. Conservation of energy. What it says is, if let's say that the particle is left from a height h onto the ground, let's say h1, and the mass is m, and the initial velocity v1 equals 0 here, and it's dropping down because of gravity, and some instant when it comes to this position where the height is h2, this is h1, and the velocity is v2 here, then what does the conservation of energy say is the sum of the kinetic and potential energies at this location is exactly equal to sum of the potential and kinetic energies here. That means 1/2 mv2 squared plus mgh2 must be equal to 1/2 mv1 squared plus mgh1. This is called conservation of mechanical energy. So energy can neither be created nor be destroyed. So if it's coming down, its height is decreasing from h1 to h2. So the potential energy is decreasing. But where did this energy go? This energy is converted in the form of kinetic energy. You can see the velocity 0 here, but it has gained a velocity here. So the velocity v2 is greater than v1. So if the height decreases, velocity increases by virtue of conservation of mechanical energy. So energy can neither be created nor be destroyed. So we'll use this equation and find what we want. If v1, h1 and h2 are given, we can find v2. So that's the model of this conservation of energy. Alright, we will talk about power now. What is power? Power is defined as P equals work over time. This is the average power. Work over time is called the average power. If a body does some work, if a force does some work on a body in a certain amount of time, then the power is defined that way. So for example, I lift a particle from this table to a height h, let's say in 2 seconds, and another person lifts it in 4 seconds to the same height, same body. So the work done by both of us is same because mgh is same, but I did it in 2 seconds, he did it in 4 seconds. So the power what I apply is greater than the power what he applied because the time taken for me is less. So if time is less, greater the power. So power can be defined as the work done per unit time, and the units of work is joule, and the power unit is watt. So you have to remember joule per second is watt. So work done is the unit joule, work done as a unit joule. Kinetic energy is the same unit as joule. Potential energy, same unit as joule. Power, watt. Remember, work done is a scalar quantity, not a vector quantity, even though it's a product of two vectors. Similarly, kinetic energy is scalar, potential energy is scalar, power is also scalar. work done, kinetic energy, potential energy and power. All the four quantities are scalar quantities, even though they utilize vector quantities and vector product. So this is about work, power, energy, conservation of energy and power. We'll meet in the next class with some problems on these topics.